Welcome grade 8s to our first video lesson as we're going to be getting into congruency, our brand new unit in this section. So in this section we're going to be diving into shapes. We're going to be diving into how shapes can compare to one another. We're going to look at how we can move shapes around a grid or a graph. Typically triangles we're going to work with. And also how we can enlarge or make bigger a shape as well as make smaller and still keep the same ratios, still keep the same angles. So we're going to start by taking a look at different shapes, and we're going to try to find out what does it mean for something to be congruent. So let's take a look at two triangles. So we're going to draw our first triangle here, and when we have a triangle that's drawn, we typically are going to label each of the corners in the triangle. So let's label that top angle A. Let's label this angle over here angle B, and this angle C. And in order to show what an angle is, or when we're talking about or referring to an angle, we would usually use what's called the angle sign. So we draw a little bit of an angle, and we would say, okay, we're going to talk now about angle A, and we would put that there. And so here, you see that we're referring to angle A, which would refer to this angle right about here. We can also sometimes talk with triangles or with any shape about different side lengths. So you could talk about, for example, side length AB. And our way of showing that is that we would say, okay, A, B, and we would put a line above to show that we're talking about a line segment A, B. We're talking about this line right here in the triangle. We can also talk about the triangle as a whole by using the triangle symbol and say, okay, we're going to be talking about triangle A, B, C. And in this case, I'm referring to this entire triangle starting at this angle, triangle A to B to C, to make this entire triangle. So let's take a look at this triangle and compare it to another triangle. Let's draw another triangle here and say that this triangle is D, E, and F. And so we want to see, are these triangles going to be congruent? And what congruency means is that the triangles have to have two things really in common. They need to be the same shape, and they need to be the same size. And if they're the same shape and the same size, then we would say that these triangles are congruent. So how can we figure out whether they're the same shape? So things that are the same shape are going to have the same angles. And so we want to make sure that if these two are congruent, that our angles match up. And right now, just by looking at it, and probably because of the way that I drew it, they don't really line up very well. But we're going to assume that they do. But in order to see that, we want to get some indication of how these angles line up. And you can either do that by figuring out what is the actual number here for this angle, or this angle, and then match it up. Or we can use special symbols to show that as well. So I'm going to kind of erase what's here, and we're going to talk about some of those symbols. So let's take a look at just one of these triangles. Let's take a look at triangle ABC. And in order to show kind of a certain angle, we would draw a little bit of a line to represent that angle. And let's say B was a different angle. So in order to show that, we might do 2 lines. And C was a different angle altogether. Yes, we might do 3 lines in order to do that. We have a curved line in each of those angles to represent that. Well, now let's take a look at our triangle DEF again. So let me just draw that in. Triangle DEF. If all of these angles matched up, for example, if D had a single line here, E had a double, and F had a triple line, we would now be able to match up these angles. We would say that angle A is the same as angle D, and we could actually write that as a bit of an equation. So angle A, we would say, equals angle D. So right here we say that this angle equals this angle. We don't know what numbers those are, but we know that because they use the same symbols that they represent the same value. we would say that angle B equals angle E. And we could also say that angle C equals angle F. So taking a look at these three bits of information, I could see, yes, this triangle is the same shape. What we don't know yet, though, is whether they're the same size. So this is a tricky thing. You can actually have two triangles or two shapes that have the exact same angles but are different sizes. And this is actually what we're going to get to later this unit when we talk about things being able to scale up or scale down. So this triangle might just be a tiny version of this one. It's a little bit bigger, and so it's not the same size anymore, but it is the same shape. So we know so far that they're the same shape. The way to make sure that they are the same size is now to check the side lengths. Is to check to see whether this side length is the same as this side length, whether BC is the same as EF, and whether CA is the same as FD. And again, just like with our angles, we can do that using special symbols, or we can do that using actual numbers. For this time around, we're going to use special symbols to show that. For our angles, we did that using little kind of half circles there, little curved lines in the angle to represent or to match up which one went with which. For side lengths, what we do is we use either a single, a double, or even sometimes a triple, depending on how many side lengths we have, line going through that to start matching them up as well. So for example, if AB and DE did match up, I might put a little line on both of those to show that this line, because the symbol that's on it, is the same length as this line. And maybe AC is the same as DF, and so I do a double line there. I kind of add a little extra. There's supposed to just be two here though. And then BC and EF, I might put a triple line to show that these match up as well. Okay, so I know that my angles match up, and now I've just figured out that my side lengths also match up. So let's erase that angle bit there. Now I could also start representing my side lengths. So I could say that side length AB, and remember side length is with a line over top, equals side length side length AB equals side length DE. I could say that BC equals, and I want to see which one BC lines up with. What other one has the three lines? It's EF. So EF. And the final one here would be that AC equals DF. So AC equals DF. Now, I chose to say AC equals DF. You could just as easily say CA equals FD. And they mean the same thing. As long as when you're matching them up, that you are starting in the angles that match. So I can't say AC equals FD. Even though technically I'm using numbers and that would technically be correct, I want to make sure that I'm matching them up properly. So that if I'm starting with this angle to refer to this line, then I do the same over here starting with angle D. So now that we've determined that they are the same shape because of the angles, and the same size because of the side lengths, we can now determine that these two triangles are actually congruent. And so we use a special symbol to represent when things are congruent. We don't just use an equal sign, we use a modified equal sign, or kind of a changed equal sign, what we call actually a congruency sign. And so we're going to refer to the triangle as a whole now. So we're going to refer to triangle ABC, and we're going to compare that to triangle DEF. And we're going to say that these triangles are congruent. And so our symbol to represent that is an equal sign with kind of a little squiggly line on top. And that represents that we have congruency